Hey class, I hope you guys are having a great day so far. We are going to jump right into lesson 17, which is solving equations and inequalities with absolute value. To start us off, I'll do the warm-up super quick. A conjunction is a compound inequality containing the word and then for both of these, if we are solving x is greater than or equal to -1 and x is less than or equal to 4, notice that that x would kind of be squished in between those values. So that would be our answer for that. So x is either between -1 or +4. So those are all the possible values in between there. Now the second one, they give us the exact same values. However, they give us this or. So in an or situation, we normally have things that are going the opposite ways. So what this is going to look like is x, if x is greater than -1, let me actually put out a number line here. So we have -1. So x is greater than or equal to that. So that's going to be going this way. And then we have x is less than or equal to, let's say 4 is over here. Those can pass each other and we get all real numbers. So you can either say all reals, or you can say this little symbol with an extra back, multiple ways to say all real numbers. Okay, so the absolute value of a number is the distance along the x-axis from the origin to the graph of the number. It is important to note that the absolute value of every number except 0 is greater than 0. So essentially what they're saying there is, in absolute values, we're not getting any negative numbers. All right? So when we take absolute values, we only get the positive of that value. So if you look here, we're taking a look at the absolute value of 7. That is just the distance from 0 to 7, which we know would be 7. They give us if x equals 0, absolute value of 0 is 0. And then if we look at the distance from 0 to -7, again, that will be a positive number because distance can't be negative. To solve absolute value equations, use inverse operations to isolate the absolute value expression on one side of the equation. Then consider the two cases. So here's our two cases. So if we have the absolute value of some number, or plus or minus some number is equal to something, so what we do is we get rid of those absolute values, and then we say that it's equal to the negative and the positive of whatever that number is. So you can see the next step, they added that a to both sides. That's kind of the way it works. The two equations above are derived or obtained from the original absolute value equation. Derived equations may result in extraneous solutions. This is a new concept for us. So extraneous solutions, these solutions do not satisfy the original absolute value equation. So essentially, if we get a value and plug it back into our equation and it doesn't work, that is an extraneous solution. So we'll be looking for those throughout this lesson. Okay, we're going to jump right into example 1. We're going to solve x minus 6 and the absolute value is equal to 4, and then we're going to graph our solution. So just like the example told us, we're going to say x minus 6 is equal to -4, and x minus 6 is equal to 4. Okay, and then it's just solving simply by adding 6 to both sides on all equations, really, since we have the same operation. So those will cancel out. We get x is equal to -4 plus 6 is 2, and x is equal to 10. So if we're graphing that, that's just going to be points. So we would have 10, we would have 2, we'd have a point there, we'd have a point there. Okay? Next, when we're solving an absolute value, we really need to isolate everything that's inside of the absolute values. So what that means is with this -5 added on, So we have solve the absolute value of 2x plus 4 and the absolute value, and we have minus 5 is equal to 1. So we have to add this 5 to both sides before we can do what we just did in that last example. So before you can say this is equal to negative 1 or positive 1, we can't do that because we have this additional term over here. So now if I want to drop the absolute values, 1 plus 5 gives us 6. So I'm going to say 2x plus 4 is equal to 6, and 2x plus 4 is equal to negative 6. Doesn't matter which order you do those in. And then the operations on the inside end up being the same. So I do minus 4, 2x is equal to 2, and divided by 2, x equals 1. On the other one, again, I'm doing minus 4, 2x is equal to negative 10, divided by 2, x equals negative 5. Okay, so let's actually go back. I said we would be looking for extraneous solutions, so I'm going to take a look at some of those right now. So if I plugged in a x equals 1, 2 times 1 is 2, plus 4 is 6, absolute value of 6 is 6, minus 5 is 1. So that works out. This negative 5, though, we have 2 times negative 5 is negative 10 plus 4, negative 6. This will work as well. So absolute value of negative 6 is positive 6, minus 5 is 1 again. So these both work. Remember to check for your extraneous solutions. Here we have solved the absolute value of 3x plus 5 equals negative 10. Okay, this is a quick one. Good thing to note. Absolute values will always be equal to positive numbers since we're dealing with distances. So if we're dealing with an absolute value and it's equal to a negative number, that's going to be no solutions. Okay, so pay attention for that. Last, we'll check for extraneous solutions here. So I'm going to drop those absolute value bars. So that'll be equal to 6x and 3x plus 18 equals negative 6x. Okay? So the first one I'll do minus 3x. So that's going to be 18 is equal to 3x. Divide by 3, x equals 6. And then I'm going to be doing minus 3x, so I have negative 9x equals 18, divided by negative 9. So I get x equals negative 2. So for this, we need to go back and plug in our answer. So if we do 6, that's going to be 18 plus 18, which is 36. Absolute value of 36 is 36. And 6 times 6 is 36. So this one's okay. The other one, however, if we do 3 times negative 2 is negative 6. Negative 6 plus 18 is 12. We get 12 over here, and then over here we get negative 12. So this does not work out for us. That's an extraneous solution. Okay? I know this first part was long, but that is the longest portion of this lesson for sure.